Kita Bbosa Science, kwano kwa beti science, rafu ya Bbosa Science, truth na beta, truth na omega, truth na alpha science.
The Science Foundation College enamave ku Lwejjinja ng'oyingira kilomita emu. Ssomero lya Dene Boarding ery'abawala n'abalenzi. Ku O-level tusomesa arts ne sciences ate A-level tusomesa sciences zokka. Omwana mulete ku The Science Foundation College. Ffe tusinga okusomesa sciences. Okumanya ebisingawo kuba ku 0753 8 27 09. The Science Foundation College, based on sciences and based for sciences.
Dr. Bbosa is a teacher at the Science Foundation College, the best school that teaches sciences. At A-level, we teach sciences only. At O-level, we teach arts and sciences. Today, 10th May 2019, we are going to consider thermodynamics. Thermodynamics deals with energy changes in a reaction. Reactions that liberate heat are called exothermic. For example, burning of firewood. 2. Reactions that absorb heat are called endothermic. For example, solubility of ammonium chloride. The amount of heat absorbed or produced in a reaction depends on 1. Amount of reactants used, 2. Temperature, 3. Pressure at which a reaction is carried out. Standard enthalpy changes. These are enthalpy changes that occur when molar quantities are involved at 298 K and 1 atmosphere. Remember that 1 atmosphere is the same as 101,325 pascals, is the same as 760 millimeters Hg. Each enthalpy change is given a name for easy identification as follows. A. Enthalpy of combustion. The standard enthalpy of combustion of a substance is enthalpy change when 1 mole of it is completely burned in oxygen at 298 K and 1 atmosphere. For example, carbon solid plus oxygen gas will give you carbon dioxide gas. Delta H is enthalpy of combustion. At 298 K and 1 atmosphere, carbon is a solid, oxygen is a gas, carbon dioxide is a gas. So when 1 mole of carbon is burned in excess oxygen to give carbon dioxide, that will be enthalpy of combustion of carbon. Methane, 4 gas plus oxygen gas will give you carbon dioxide gas plus water, liquid. Delta H is enthalpy of combustion. To balance the equation, we put 2 and we put 2. So the enthalpy change when 1 mole of methane is burned in oxygen to give carbon dioxide and the water is enthalpy of combustion of methane. Experiment to determine the enthalpy of combustion of a substance. The principle, a given mass M of a substance of molecular mass Mr is burnt in excess oxygen. The heat liberated is used to raise the temperature of a given mass of water through 50 degrees Celsius. Heat liberated is equal to heat gained by water. Heat gained by water will be mw times c times theta, where c is specific heat capacity of water. It implies that m grams of a substance liberate mw c theta joules. Therefore, the molecular mass of a substance liberate mw c theta times mr over m, that is joules per mole. The setup will depend on the nature of a substance. If it is a liquid, a speedy candle may be used. If it is a solid, we use a colorimetric bomb. Experimental setup for determination of enthalpy of combustion of a liquid fuel. For example, ethanol. We shall have a thermometer to measure the temperature change, theta. Then water of mass mw grams. Then we shall also have a speedy candle. The difference in the masses before and after, which is equal to m grams, is equal to the mass of the fuel burnt. What we do, weigh a speedy candle and light it to heat mw grams of water at 50 degrees Celsius. Put off the light and weigh the candle again. The difference in the mass before and after will be the mass of the fuel burnt. Then heat absorbed by water, heat absorbed by water will be equal to mw c theta. It implies that m grams of a substance liberate mw c theta. Therefore, the heat liberated by a substance mr will be equal to mw c theta over m joules per mole. Colorimetric bomb for determination of enthalpy of combustion of a solid substance, for example sugar, carbon and sulfur. So the substance is put in a crucible C. The bomb is filled with oxygen. This is the bomb. Is filled with oxygen, and the substance ignited by the coil W. It burns and liberates heat. The heat raises the temperature of water of mass mw through 50 degrees Celsius. Then the heat liberated by the substance is equal to heat gained by water. Heat gained by water is equal to mc theta. It implies that m grams of the substance liberate mw c theta joules. Therefore, the molecular mass of the substance will liberate mw c theta over m joules per mole. B is enthalpy formation of a compound. Standard molar enthalpy of formation of a compound is the enthalpy change when 1 mole of the compound is formed from its elements at 298 K and 1 atmosphere. For example, water, 1 mole of water formed from hydrogen and oxygen. At 298 K and 1 atmosphere, water is a liquid, oxygen is a gas, hydrogen is a gas. Then the ensamples formation of calcium chloride from chlorine and calcium. At 298 K and 1 atmosphere, calcium is a solid, chlorine is a gas, calcium chloride is a solid. Similarly, aluminium plus oxygen, you get aluminium oxide, Nb, ensamples formation of an element at 298 K and 1 atmosphere is 0. See, ensamples formation of added ions is enthalpy change when 1 mole of added ion is formed from an element at 298 K and 1 atmosphere. For example, sodium at 298 K and 1 atmosphere is a solid, plus aqueous, you get sodium ion aqueous, delta H is negative to 40 degrees joules per mole. Similarly, calcium solid plus aqueous, you get calcium 2 plus aqueous, delta H is formation of hydrated ions. D, enthalpy of atomization, reverse to enthalpy change when 1 mole of gaseous atom is formed from an element at 298 K and 1 atmosphere. For example, 1 mole of calcium atoms is formed from calcium solid at 298 K and 1 atmosphere will be enthalpy of atomization. 1 mole of hydrogen atom is formed from half a mole of hydrogen molecules, gas. It will be the enthalpy of atomization. Related to enthalpy of atomization is bond energy. Is enthalpy change when 1 mole of a covalent bond is formed from gaseous atom, or enthalpy change when 1 mole of a covalent bond is broken into gaseous atoms. Gaseous atoms. For example, hydrogen gas will break into hydrogen atoms, 2 moles. What I want you to be careful here, that when you talk about bond energy, you get 2 moles of atoms. When they talk about atomization energy, you talk about 1 mole of gaseous atoms. So they will confuse you in the calculation mentioning enthalpy of atomization of hydrogen, where you produce 1 mole of hydrogen atom, or bond dissociation of hydrogen atoms, which will produce 2 moles of hydrogen atoms, or 2 moles of chlorine atoms. F, enthalpy of ionization, refers to enthalpy change when 1 mole of gaseous ion is formed from gaseous atom or ions. So calcium gas to calcium positive 1 plus an electron, you get first ionization energy. Then calcium positive 1 to calcium positive 2 becomes second ionization energy. Calcium positive 2 to calcium positive 3 refers to third ionization energy. Definition: first ionization energy is enthalpy change when 1 mole of gaseous atom with a single positive charge is formed from 1 mole of gaseous atoms. Factors affecting the magnitude of first ionization energy. 1. Size of an atom. Small atoms have strong attraction to outermost electrons, leading to high ionization energy. 2. Electronegativity. Highly electronegative atoms have high ionization energy due to strong nuclear charge on the valence electron. 3. Electropositivity. highly electropositive elements have low attraction to valence electron, leading to low ionization energy. Then for electron configuration, atoms with stable electronic configuration or full orbital have high ionization energy compared to other elements. G, electron affinity, is enthalpy change when gaseous anions are formed from one mole of gaseous atoms or anions. So chlorine plus one electron, you get chlorine minus. That is the first electron affinity. Oxygen minus plus an electron, you get oxygen minus 2. You get second electron affinity. H, that's enthalpy, is enthalpy change when one mole of crystal lattice is formed from its component gaseous ions. For example, sodium ion gas plus chloride ion gas, you get sodium chloride solid. Enthalpy change is lattice. Calcium 2 plus gas plus chloride ion gas, you get calcium chloride solid. Enthalpy change is lattice. Factors affecting lattice enthalpy. One is the size of the ions. Smaller ions form strong lattice due to strong attraction between a cation and an ion. Then two charges on ions. The bigger the charges on ions, the bigger the lattice energy due to strong attraction. I is enthalpy of solution, is enthalpy change when one mole of an aqueous solid is dissolved in excess solvent or water. For example, sodium chloride solid goes into sodium ions and chloride ion. Then J, enthalpy of solution is equal to lattice energy plus hydration energy. Then J, hydration energy, is enthalpy change when one mole of gaseous ion is dissolved in excess water. For example, sodium gas plus aqueous, you get sodium aqueous. The enthalpy change is enthalpy of hydration. Enthalpy of neutralization is enthalpy change when one mole of water is formed from one mole of aqueous hydrogen ions and one mole of aqueous OH ions. Hydrogen ion is aqueous plus OH aqueous is equal to one mole of water. Enthalpy of reaction is enthalpy change which occur when one mole of a compound is formed from its reactants. For example, ammonia plus HCl, you get ammonium chloride. The enthalpy of reaction will be equal to the sum of enthalpy formation of the product minus the sum of formation of the reactants. Omutima kwe guteeterera azalibwa bakungu yakuzibwa bulungi atambula bulungi oba kiriba kitya ng'ono nsuula naye nga
tulya naye oba muyaga gutya oba buzibu butya ono tufa naye ono yabasinga yono yeye omutima kwe guteeterera bulamu kwe butambulira oba butiti butya oba kwaka gutya ono ndifa naye era ndiba naye mubalungi gwe nnonze mubalungi gwe nfiira mubalagavu mulungi